Hello everyone, in this video we are going to see some IMP questions from subject Engineering Mechanics first year. These are the questions required for DIVA2 University especially. So let's see. First here the question is given, the equation of motion of an engine is given by S is equal to 2t cube minus 6t square minus 8, where S is in meters and T is in seconds. Calculate first displacement and acceleration when velocity is 0, and second is the displacement and velocity when acceleration is 0. So here first we are given the equation of motion, that is S is equal to 2t cube minus 6t square minus 8, where S is in displacement in meters and T is time in seconds. So we have asked to find displacement and acceleration when velocity is 0, and second is displacement and velocity when acceleration is 0. So first here our step 1 is to find velocity and acceleration. So to solve this, you first differentiate s of t to get velocity and acceleration. Velocity v is equal to ds by dt. V is equal to differentiating 2t cube minus 6t square minus 8. So we will get 6t square minus 12t. So acceleration is, we get acceleration by differentiating velocity. So by differentiating it, we will get 12t minus 12. So first is when velocity is 0. So velocity we got is 6t square minus 12t is equal to 0. Then we get t is equal to 0 or t is equal to 2. Now plug into the original displacement S and acceleration A formulas. At t is equal to 0, S is equal to minus 8 meter and A is equal to minus 12 meter per second square, and at t is equal to S is equal to minus 16 meter and A is equal to 12 meter per second square. So at time is equal to 0, we got displacement acceleration, and time is equal to 2, we also got displacement acceleration. So this two values we got. So when acceleration is 0, part 2 is so solve for a equal to 0. So 20 minus 12 is 0. T is equal to 1 second. So now put it into S and V. S is equal to minus 12 meter and V is equal to minus 6 meter per second. So here we got only one value of displacement and velocity. So these are the very easy examples, you can practice it. So this uses calculus to analyze motion described by a given position time function. So this is very easy, study it, don't skip it. So here we next see next example. Question is, a string ABCD attached to fixed points A and D has two equal weights of 1000 N attached to it at B and C. The weights raised with the positions AB and CD inclined at angles. Find the tensions in the portions AB, BC and CD of the string if the inclination of the portion BC with the vertical is 120 degree. So here you have given only this figure. So first, by using Lami's theorem, tension upon AB upon sine 60 degree. So it is like that. Lami's theorem is that tension upon opposite force to that tension. So here tension upon AB upon sine 60 degree is equal to tension upon BC upon sine 150 degree is equal to 1000 upon sine 150 degree. For tension in AB is equal to 1000 into sine 60 degree upon sine 150 degree. So tension in AB is 1732.05 N. tension in BC is equal to 1000 into sine 150 upon sine 150. So tension in BC is 1000 N. So now considering string BCD and drawing FBD, and draw FBD of figure 8 like shown in below figure. So like you will get this figure. So by using Lami's theorem, tension in BC 1000 upon sine 120 degree is equal to tension in CD upon sine 120 degree is equal to 1000 upon sine 120 degree. So tension in CD is equal to 1000 into sine 120 degree upon sine 120 degree. So tension in CD is 1000 N. So now we will see a theory question, theory concept, that is motion with uniform acceleration. So first consider the motion of a body with uniform acceleration A. Let U is equal to initial velocity, V is equal to final velocity, and T is the time taken for change of velocity from U to V. U equal to initial velocity means velocity from which starts, and acceleration is defined as the rate of change of velocity. Since it is uniform, we can write as A is equal to V minus U upon T. So V is equal to U plus AT. So here next displacement S is given by S is equal to average velocity into time is equal to U plus V upon 2 into T. Substituting the value of V from equation 12.2 into equation 12.3. From previous equation we are putting this values in this. S is equal to U plus AT upon 2 into T. So we will get UT plus half AT square. So you see it as equation 4. So from equation 2, substituting it in equation 3. So S is equal to U plus V upon 2 into V minus U upon A. So we will get V square minus U square upon 2A. That is V square minus U square is equal to AS. So thus equations of motion of a body moving with constant acceleration are V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. These are the three equations of motion of a body. Now we will see variance theorem. So French mathematician Varigon gave the following theorem, which is also known as principle of moments. So Varigon's theorem states that the algebraic sum of moments of a system of coplanar forces about a moment center is equal to the moment of the resultant force about the same moment center. So theorem says that here we will see the proof. Referring to below figure 3.3, let R be the resultant forces F1 and F2 and O be the moment center. Let D, D1 and D2 be the moment arms of the forces R, F1 and F2 respectively. Then in this case we have to prove that RD is equal to F1 D1 plus F2 D2. So draw these figures, join OA and consider it as y-axis. Draw x-axis to it with A as origin. Let the resultant R makes an angle theta with x-axis. Nothing that angle AOB is also theta. We can write RD is equal to R into AO cos theta. AO into R cos theta is equal to AO into RX, where Rx denotes the component of R in x direction. Similarly, if F1x and F2x are the components of F1 and F2 in x direction respectively, then F1 D1 is equal to AO F1x and F2 D2 is equal to AO F2x. So here's the proof given. So thus the moment of resultant of a number of forces about a moment center is equal to the sum of moments of its component forces about the same moment force. You can refer these notes while writing in your exams and while preparing for exams. Thank you.